The LG Procast is intended for informational and entertainment purposes only. The views or opinions expressed by the podcast hosts and guests do not necessarily reflect the official position of LG. For the latest and most accurate information about LG products, please consult relevant product manuals and related documentation.
Welcome back to another episode of the LG Procast. I'm Phillip Kriegbaum.
And I'm Terry Frisenda. Today we're here at Meier Supply in Conklin, New York, and we're going to talk about low load, the new HVAC challenge.
It absolutely is a new challenge for us.
Phillip, tell the audience what you mean or what we mean by a low load structure.
Yeah, so what we're talking about is, house design, house construction, the building science that goes into it, really directly relates to the air conditioning design. So we've got homes, you've got spray foam and you've got AeroSeal products and you've got zip wall construction and several others that are making these homes extremely airtight. And then the insulation has gotten so much better. The windows have gotten so much better. So we've got homes that, 50 years ago might have taken 6, 7, 8 tons to cool a home. And now we're doing them with 2 and 3 tons. And it's created a huge challenge for the guys that are designing air conditioning systems and heating systems.
If I hear you right, a home that was built 30 or 40 years ago, maybe 50 years ago, whatever the case is, leaked, right? Had air infiltration, and that impacted the size of the heating and cooling system. And now as these methods of construction become tighter and tighter, there's not that leaking. And the infiltration is not as much. The loss is not as much. So that's impacting the size of the HVAC systems. So that old adage of, take a 3-ton out and put a 3-ton back in may not be the case, because you don't know, unless you ask the right questions, you don't know as a contractor if they've done things to change that envelope. Is that what I'm hearing from you?
Yeah, I mean, you've got several things that are going on. So you have the replacement issue where what if they've had that house aerosealed? What if they've changed the windows? What if they've added additional insulation in the attic or a power vented attic fan to reduce the temperature of the attic? So without doing a proper load calc and really doing a blower door test to know the leakage of the home, going back with the exact same size is you never know. You never know.
Right.
It's a shot
you
in the
don't
dark.
know. And then, of course, then you add onto that the fact that, a lot of the HVAC trade over the past has had this mentality of bigger's better, right? And you couple that with this phenomenon of decreasing loads in these spaces, and you end up in a nightmare. And listen, that nightmare in the South is cold and clammy rooms.
Yeah.
And I know you've all been in a home where it's cool in the home, but it feels damp. And that's not a comfortable environment.
Well, and you and I both live in the South, so I mean, we know. And it's funny, every air conditioning contractor I talk to, when you talk to them, they know bigger's not better, but they're all scared because they don't do the load calcs or they don't trust the load calc. And so they end up going, well, maybe I'll bump it a ton or a half a ton, and I'll cover myself. And they know they're not supposed to. They know it's going to create an issue, but they're scared of getting the call, hey, my house is not maintaining the temperature that I set it at. Well, if they can keep the temperature to the homeowner, then they feel like, they're not going to get the complaint calls. But the comfort's not there. Yeah,
the comfort's not there. It sounds like they're, again, working with standard systems that have a fixed speed or a fixed output. That's probably a better way to say
Oftentimes.
30,000 BTU output is 30,000 BTU output. They don't have an inverter-driven system like an LG heat pump that can change its capacity via changing the hertz on the compressor. So we're trying to educate this group, the contractor group and the builder group, right, and developer group, that there is an option, right, and the option is get a variable capacity system and put it in your homes. That way it can adjust to these load changes, and I think the more that we can do that messaging, the better this will be for everyone.
Right, for sure. And sizing is still important, but to your point, it definitely gives you a whole lot more flexibility that's there. You still can't take a 4-ton unit and put it on a 2-ton house. You're still going to have problems, which I've seen guys try to do. Oh, it's an inverter, it'll ramp down. But the range is drastically different. And so you do have that flexibility. And when you size them right, then you really get the optimal performance, where when that load changes early in the morning, late in the evening, in the fall, in the spring, we've always got the the capacity range to match what the load is on the house for just about
it's
every day.
I think it's important for our audience to understand that on a variable capacity system, if I've got this 3-ton system and it has an operational range of, minimum capacity, and I'm making these numbers up as I go, minimum capacity of 10,000 BTUs and maximum of 42,000 BTUs, understand that when it's running below 36,000 BTUs, that's a different energy consumption than it's running at 36 or 42,000 BTUs. Yeah. And that's really what you want with a system, because you don't need all the cooling or heating of your system all the time. But if you have that constant speed system, that's what you get. And with a variable capacity system like an LG heat pump, when I'm down there running at something less than its rated capacity, I'm consuming less electricity, and that's what people want, right?
Right.
You get comfort and you get efficiency, so that's a win-win for both.
When everybody fixates on the SEER rating, or now SEER 2 rating, and yes, that's important, and yes, it is relevant, but when you're comparing an inverter system that's not always running at its rated capacity, like to your point, if you have a 3-ton system and we're only producing 22,000 BTUs at this moment, and maybe it's an 18 or a 20 SEER system. Well, it's not an 18 or 20 SEER system at that point. It's substantially more.
It's something
and
different, right?
There's not currently a way to rate that by HRI. We don't have part load ratings yet.
Yeah, but what we definitely see is we see it in the if you aren't a technician, you'll see it in your amp meter. If you got you put a amp probe on there and you find out, hey, it's only pulling 3 or 4 amps and it's satisfying the space temperature, as a technician, this is not consuming.
Well, if you're a homeowner, you see it in your power bill.
You see it in your power bill.
Yeah.
Absolutely. Yeah. Absolutely. And, I know you get asked and I get asked, and I'm sure all the contractors and folks listening get asked as well. Well, how much can it save me? It's such a impossible question to answer, because everyone's home is different. Everyone's use is different. Everyone's climate is different. So there's no, it saves you 50% or 60%. I would walk away from somebody that told me that they have a hard number. It can save you this much. It's moving target.
We can do some estimations, and there are some pretty complex calculations where they can,
pin it down closer.
They can get pretty close. I mean, we've got some guys in our engineering team that have taken some commercial projects for us and taken the comparison of a new commercial project and go, hey, if we were going to put 14 SEER standard rooftop systems on there.
Energy modeling.
Right, energy modeling.
Gotcha.
Yeah. And so we can get, a pretty good idea of what the savings are going to look like. But to your point, if somebody just comes to you and says, hey, I
can save you 70%. Right. That's just, be wary of that.
Right.
We're trying to talk and educate folks.
But the savings are significant.
They are significant.
Yeah. I mean, I wouldn't say they can't be 70%.
I wouldn't either. I mean, I live in a home with an inverter-driven product, so I know what it can do.
Yeah.
And I can look at my neighbor's house and have the same size system and same house, and yep, they may live different than me, but
right.
I know their power bill versus my power bill. So one by one, I'm replacing them in my neighborhood too.
I've talked to my neighbor recently too, and he's like, "That's
if
that's
it's nothing else, it's for noise, right?"
Oh, they're so quiet.
So low load. Listen, I want to give you a real life example. Years ago in the early 80s, I was doing some home building HVAC new construction work for a very prominent Florida builder. He built custom homes in the Sarasota market, so the high-end market. The homes were large, 4,000, 5,000 square feet. And I can tell you, because in the state of Florida, even that long ago, we had to run manual J load calcs in that state to get a permit. So those homes were coming in at 9 and 10 tons of cooling on that footprint. Very common footprint. Matter of fact, his son is still building those homes today. That's kind of where I'm headed with this story. So we were doing these homes 9 and 10 tons using a U.S. built product to do it, constant speed, ductwork, just like the world or like the U.S. uses. I got involved with his son, who's a second generation, I guess you could call that now, and went to school and got educated on building science and started changing the way his dad built these houses, and started to use better windows and better insulation and different construction techniques. The gist of the story is that same footprint that his dad built and that I did the air conditioning work for as a contractor at 10 tons is now just over 38,000 BTUs of cooling.
What a difference.
In that home in Sarasota, Florida. That's a third the size that it used to be, right? Now, that presented a problem because having a fixed speed system with ductwork that can go through 4,000 or 5,000 square feet at 36 or 38,000 BTUs, that's a challenge, right? That's a very big challenge for contractors as we build these structures. But it wasn't a challenge for us because we used ducted product and we used multiple small capacity indoor units, and we zoned that home accordingly, right? We put some like bedrooms and some like zones together on small ducted platforms, and we manage those homes that way today, and we're still building them today. And it's a very effective and efficient way to do these homes that are creating these challenges for traditional HVAC work.
Yeah. So, I think what you're saying is instead of zoning it with very large duct systems, which is fairly impossible to do well with that low of a load on that large of a footprint, we're sending the refrigerant to the area of the home that it needs to do the work in, and then putting a small capacity system for that section of the house.
Absolutely. And it allows people, you go back to the way those homes are built and who they're built for down there. They're big homes, and it's typically, husband and wife my age living in them, right? And the kids come at Thanksgiving or Christmas or whatever, and then there's 10 people there, but the other times of the year, no one's there. So they can effectively not shut them off. You don't really want to do that, but you can raise those set points in those unused zones, which is reducing the required capacity of the outdoor system, which is reducing the electric consumption. So that's what this technology is about. And so whether we're doing, these new passive low load homes, and I got to tell you, man, some of the stuff is crazy. I am literally doing a house right now in Washington, the state of Washington, on an island, 6,600 square feet with a 33,000 BTU heating load and 18,000 BTU cooling load. That's just a challenge, and it's 3 stories. So how do you do those kind of those kind of stories? You have to have something different 100%. Than what the world or what the U.S. has been using all along.
Well, and as we get tighter and tighter and more energy efficient, we're even getting to the point now where even with our products, it's becoming a challenge for some of these rooms. And we're having to kind of take a step back into the basics and start looking at air share devices, fans that can move air. Transfer fans, things like that. I mean, there is not necessarily a need to put a duct drop in every room. I've got apartments going up in Kentucky. It's a 2-bedroom apartment, 1 large living area, and we're doing it with a 1-zone wall-mounted single-zone mini-split system, for lack of a better term, and they're using air share fans to push air into these bedrooms. You give it a return path out, and it's great. It's reduced the cost for the developer, for the builder to put the system in. It's reduced the energy consumption because what they were using before was a 3-zone system. They were putting a head in each bedroom, and the tenants are loving it. They finding it's actually much more comfortable than having a head in the bedroom because it wasn't sized even anywhere close. They've got a 6,000-7,000 BTU head in that bedroom that was needing, probably in the hundreds or low thousands at the most.
Yeah, 1,200 BTUs maximum.
Right. And so it's never comfortable. It was short cycling all the time. So now they're just constantly pushing air through these bedrooms. It's returning back to the living room system, and they're loving it.
Yeah, one of the things that has certainly come out of building tighter and tighter homes, ASHRAE 62.2, I think it is, with fresh air ventilation. These contractors, we have to make sure that we're adhering to 62.2 and ventilating these homes properly, right? Because they are so tight, you have got to bring fresh air into these homes, and that does impact the load. And so there's choices out there to how you want to do that. But, the message there is, the tighter we build these houses, the more that ventilation, the more the air share, the more that things like fan strategies come into play. And that's a contractor that's on the leading edge of what's going on in his industry.
We got to reclaim, somebody said it, and I don't remember who it was, but they said it to us. We have to reclaim the ceiling fans. Those devices are made to move air throughout the room.
Yes.
We don't necessarily have to push the air or distribute the air with the HVAC system. We have other means to move that air, and fans are a piece of that puzzle.
Fan strategy is a term I use quite often.
Yeah. And talking about the ventilation, that's become more and more and more important. And, Terry, I took psychrometrics twice by a really good instructor when I was in Louisiana, and I might have remembered this much of it, but
if you ever look at that chart, you'll understand why.
The one takeaway that I got from his class was that in South Louisiana, ERVs didn't even work. and he proved it based on the chart. He's like, there's no ERV on the market that can deal with the amount of humidity that we have. So what we were doing is we were using a dehumidifier for the fresh air, bringing that in, and that was doing a great job. So we did those on all of our like foam encapsulated houses and things like that. And that was several years ago. And things have gotten even tighter and more efficient. But to the technicians out there, psychrometrics may seem a little bit scary, but you need to get into a class. You need to learn what your market, what your conditions are. Because if you're in the deep, deep South, ERVs may not even be enough. And heaven forbid, I hate to say it, but if you're one of those guys that's just dropping a 6-inch duct in the soffit and pumping it into the return and expecting your heating and cooling system to be able to deal with that humidity, you're fooling yourself, because it's not going to happen.
Yeah, it's overwhelming and cold.
Oh, yeah.
Absolutely.
You'll never get that house dry.
Right, you'll never do it. So, well, low load's not going away, just like inverter-driven products not going away.
100%.
Right? So I think from an audience standpoint, the sooner and better that you can adapt to a strategy using fans and transfer fans and smaller capacity indoor units and get away from that unit in every room mentality, I think you're way ahead of the game as a contractor.
Oh, I do too. And I think the transfer fans is really the thing that, if I were a young technician or a designer in the residential world right now, and I guess I kind of am, because I work with a lot of those guys, but understanding how to move air into rooms, one of the most popular ones that I get is, how do I deal with this master closet? It's as big as a bedroom just about in some of these houses. Right. I mean, when you have a his and a hers walk-in closet, I've seen some house plans and I'm like, good gracious. I mean, their closet's as big as my dining room, but nobody lives in there. There's very little load in there because there's no exterior walls oftentimes. So you have a tiny, tiny load, but you need a little bit of air moving through that room so that it's staying fresh, and you do have some load sometimes from the ceiling or something like that. So a transfer fan is a phenomenal way to handle a room like that.
Yeah, because last thing, I've had applications where I've tried to mount a horizontal ducted unit in that primary bedroom closet by dropping the ceiling, but then I'm faced with, all right, where do I put my return air? Because you certainly don't want to pull the return air out of the closet, and then I understand. But getting air in and out of a large walk-in closet, certainly. I know these home builders that you and I deal with. All walk-in closets are conditioned, right? There's none that aren't conditioned. So that's it from a low load structure. It's a challenge for traditional HVAC work. It can be solved easily and readily with inverter-driven products. All right, particularly when you can do ducted and ductless in an application like that, and have multiple indoor units from a single outdoor. It's not a challenge for our technology and for our product line. So find your local LG HVAC distributor and contractor. Yeah. And go to work on this product line. I think you'll be very happy.
Yeah. The other room that I want to step back and mention that I get asked about a lot is bathrooms.
Yeah.
How do we deal with, great, we've got some bathrooms that are, monstrous,
strategy, right?
But how do you deal with a small bathroom? And transfer fan may not be ideal because we don't want to send odors and humidity back into the space, but what are your thoughts on these ventilation fans, these constant speed fans?
I'm a huge fan, that, right?
They run at 20 CFM, I believe, or something very, very low. So you've constantly got a small negative pressure on the home, but then they sense humidity and or human presence, occupancy, and then they ramp up to whatever you have them set at, 80, 90, 100. And I tell guys, that's how I handle the bathroom. You've got that little bit of draft that's bringing in some conditioned air. And then when you enter, it's going to ramp up the amount of conditioned air that it's going to pull. And you have to give it a path in, whether that's under the door, a 1-inch gap will give you about 60 CFM of passageway. But as long as you give that air a path to come in and then you're exhausting it outside, you're removing the humidity and you're removing the odors. But at the same time, you're bringing in your conditioned air. And so guys are like, well, what do I do with the bathroom? Put a vent fan in. And if you don't want to use one of those, you want to go something basic, I wire it in with a light switch.
Well, they're certainly quieter and more energy efficient than they used to be, right?
Oh, for sure. Yeah.
And if you go back to an earlier podcast where we talked to Ryan Strong at Palpac, he's using our air-to-water heat pump and making the bathroom floors heated. So there's a way to to provide the heat for the floor, but still to exhaust the air and use that from a condition standpoint. So That's craftsmanship. That's trade quality. That's guys figuring out how to use the tools that they have and the products that are available to create better and comfort environments for folks in the homes they live in.
It's taken a moment to think about something and maybe go a little bit outside of the box that we've drawn for ourselves for so many years and figuring out a solution. You know, a lot of these guys, they know it. It's just they've gotten into this rut of, well, this is how I've done it. This is how my dad taught me. This is how my pawpaw taught me, and his pawpaw taught me years and years and years ago. Well, guys, I mean, yeah, refrigeration cycle is the same as 100 years ago, but it's not.
The way it's managed is not the same.
Yeah, we're not using it the same way. We're certainly not building our homes the same way. I mean, I've done one of the craziest houses I ever did was in Louisiana, and a guy came to us and said, hey, I've got this home, never had any heat and air in it before. And, okay, what are the walls made out of? Well, there's mud and moss packed in the walls. And yeah, so that was
his insulation, mud and moss?
Mud and moss.
A lot of that available in Louisiana.
There was plenty of it, you know, and then the attic had no insulation. So we were able to do that, but that was a fun project because it had nothing. So we took it from ground level all the way, put a central heating and air system in there, and it came out really, really awesome. But that was a little challenging. We had to think outside the box.
If I think about an opportunity where low load bit me in the tail feathers, okay, had a contractor install that strategy and some tight construction condos, if you will, on an ocean in Florida, and they were latent nightmares. In other words, they could not control the humidity in these spaces. They short cycled. Mm-hmm. They were cold and damp rooms. And when, you know, everyone's involved, you know, and the building science folks are involved. And ultimately the decision that was made by the designing engineer was, you guys need some load in this room. And he literally looked at the builder and said, you should buy like a little heater or something and put some load into this home, into this space. And everyone just looked at each other like, okay, so we're all at fault because you designed it, over-designed it, oversized it because bigger's better, and now we're supposed to plug in a heater in this. So it was
probably an electric heater.
Yeah, exactly. So
COP of 1.
The builder looked at me like, and so it can be a problem if you let it be a problem. So
absolutely.
Use your minds. Think. Run a load calc. Run a load calc, run a load calc. If you need to refer back to a previous episode where we had Alex on here from Calc, learn, watch, but run a load calc.
Yeah. Like you said, if you have questions, if you don't understand it, learn. If you don't want to learn or can't learn, pay someone to do it. I mean, to me, it's opening yourself up to this massive liability. It's cheaper to pay someone to do a load calc than to reinstall the system or to go back out there 1,400 times trying to solve the problem, or worse, get involved in a lawsuit because it wasn't done right the first time. And
nobody wants an unhappy customer. I don't know any air conditioning contractors out there that are out there saying, I don't want to make this guy unhappy. Right?
No, it's part of the job.
It's part of
you
your
need to budget in whatever it costs to have a load calc done.
Listen, man, I can tell you there's companies out there that use that as a selling strategy. They will come behind an HVAC retrofit contractor and say, did XYZ run a load calc on your home for you?
I did it every day.
Right. Every home, right? Every call. And if you're not that sophisticated, as Phillip said, then pay someone to do that for you. It's not nearly as expensive as you think it is. No. So get involved, learn what we're doing, use the podcast for resources, but run a load calc.
Yeah. And
know what you're dealing with.
Really, you should be doing it yourself. I mean, there is software out there that makes it so easy. There's software now. LG's partnering with a company called Conduit. You literally take an iPad Pro and you walk around this room and you scan the room, and it's using this LiDAR sensor and it measures the room. And I mean, 10, 12 minutes, you can have the entire manual J calculation done accurately. Just you gotta invest in the tools that are going to make you successful. But then when you go to sell the job, you quoted a 4-ton, and I come right behind you, and I'm going, hey, man, you don't need a 4-ton in your house, and here's how I can prove it to you. Guess who's getting the sale?
Yep, absolutely.
I am. I just took everything that you told them in your presentation and made it look
debunked.
Yeah, absolutely.
Listen, LG Pro dealers, That's the kind of contractor you want at your home, all right? Because these are the guys that are going to do it right,
Yep.
and they're gonna run these load calcs. They're gonna do the steps and the tools to make sure that the comfort going in your home is the comfort you need.
Absolutely, absolutely. Yeah, and check out that episode. I think it aired back in August with Alex Meany. So check that one out. Tune in and
Super.
Awesome.
Till the next episode. Thank you very much.